So the formal definition of a circle is all the points that are equidistant from some center. You have to specify how far away from the center you want the circle to be, but that's just defining what the radius is. So if we have a circle, the distance from the center to the edge of the circle is the radius, just to review. And two radii is the diameter. So diameter equals 2 times the radius, or the radius equals half of the diameter. These terms, hopefully we already know. There's a couple that we don't maybe necessarily know. So I'm going to say those real quick right now. So I'm going to draw a circle. There's the center. I'll call this C. So this will be circle C. That's how you can say it. Instead of like the triangle symbol for triangles, we just do a circle with the center. A chord is, that was bad. A chord is a segment that joins 2 points on the circle. That's what a chord is. For some reason I think of a guitar, but those are strings, not chords. So chord is a segment that joins 2 points on the circle. A secant line is a line. So this is a segment. It has 2 endpoints. This is a line. It just keeps going on and on and on. This is called a secant line. So this is a line. So it's different than a segment. A line that passes through the circle at 2 points. It's kind of like you take a chord and you just extend onwards. So a secant is a line that passes through the circle at 2 points. And then we have another thing. Does anyone know what that line is called? Wait, actually, secant. Write that. Does anyone know what this bottom line is called? No? That's the tangent line. So a tangent line touches the circle in exactly 1 point. It's lying flat with the circle. It's on the same plane as the circle, and it only touches the tangent once. So if you had, like, here, don't draw this, but if you had something like this, where the circle, pretend it's like 3-dimensional, and the line was going this way, that would not be considered tangent. The circle has to be flat with the line. That's a tangent. So tangent is a line also that passes through the circle at 2 points. Sorry, at 1 point. That passes through the circle at exactly 1 point. So tangent, secant, chord, diameter, radius, all very simple stuff. Oh, one more thing. This point here, there's a name for it. It's very, very, very obvious. This point is the point of tangency, which should make sense, but I'm not going to write down the definition for that one. Point of tangency. You're trying to identify any chord that you see, any radius that you see, any diameter that you see, any secant line that you see, any tangent line that you see. You're trying to list any point of tangency that you're looking or that you can see. You will repeat some of these segments and name them different things. So that's what you're doing. Identify each line or segment that intersects with circle P. PQ is a radius. Remember, when we're naming, we have to put the segment. It is a segment, so PQ is a radius. So I'm going to say radius. U is a point of tangency. Yes, point of tangency. Perfect, and you just label it with just a single letter because it's a point. The segment ST is a diameter. QR is a chord. What else? There's still plenty more. So make sure you have the arrows there. UV is a tangent line. So make sure you have those arrows there. ST with the arrows is a secant. Very good. SP is a radius. I wrote too big. I think that's maybe all of them. So depending on whether you're continuing it as a line, ST would be a secant line. That's what we have here. Or if you stop it and say, okay, well, from here to here, if you're just considering that segment, then yeah, that's a chord as well. So just careful with that. And so we named some lines going through the circle, but the lengths of the curved portions of the circle, we're going to call arcs, A-R-C. So what I'm going to say here, I don't know if you'll be able to see this, but I'm going to color in red from J to K. That doesn't look great, but oh well. And I'm going to call that arc, JK. So later on we'll be able to figure out those lengths based on some other theorems. But right now we're just naming it. So that's length JK. And then also that's called the minor arc. Just because it's the shortest distance between J and K. The major arc would be going backwards all the way around. So that would be the major arc. I don't know if you can see this, but that would be, since we're going the other way, we'll say J, M, K with a little arc mark over it. So this would be the major arc. It's not an E, that's a C. This doesn't write well on that. Oh well. The next thing I want to talk about is the ratio of circumference to diameter. So the ratio of the circumference to the diameter. First of all, the circumference just to remind you, is the distance all the way around the circle. Distance all the way around the circle, the circle And the diameter, of course, is the distance through, I guess I wasn't writing the whole time, through the center from, it's the chord that goes through the center. That's the diameter. So circumference is the distance all the way around, and the diameter is the chord, or the distance of the chord that passes through the center of the circle. So a long time ago, someone was trying to measure, maybe like with a piece of rope or something, they were trying to measure the distance around the circle, and then they'd unroll it and then measure that, and then they would divide it by the diameter, and they noticed something, that each time they did this, for whatever circle, they got a certain number. Does anyone know what that number is? What? Yeah, it's pi. If you have the circle divided by the diameter, no matter what, you will get pi, which is 3.1415926 5, I think. Onwards and onwards and onwards. No matter what circle, if you take the circumference and divide it by the diameter, you get pi. This is something that we could actually try if we could measure the curved surface and we had time. I think it would be a cool activity because you would always get something that's really close to 3 and a little bit more, like 3 point something. So that is where, just by drawing a circle, measuring the circumference, and measuring the diameter and dividing those, that's where you can get closer and closer and closer to pi, even though you can't exactly measure it, but as accurate as you can. We'll just give you more decimal places. That's where we get the formula. If we multiply both sides by d, then circumference gives you pi times diameter, or circumference is, since the diameter is just 2 times the radius, you can say 2 times pi times the radius. Those are the same formula. That's where it comes from, just by multiplying both sides by the diameter. And then area comes from some other stuff, but these are the basic ones that we're going to look at. I'll write down the area formula as well. So area is pi r squared. We have square units for the area. Later on, we're going to be looking at, instead of just arcs, we're going to find the arc length. That's going to be something. We're also going to find the area of a sector, which will be like a little pizza slice. How big is that pizza slice? That's what the area would be. But I wanted to show you, for the last part, that this is true. So we'll see. That'll be the end of the notes that you have to write down, but I want to show you this and have you pay attention.